Guys, now we have a crate here with a mass of 4 kg, and then Sipho is pushing this. Sipho is pushing this to our right hand side. He's pushing this box to our right hand side with a velocity of 2 meters per second. Of 2 meters per second from rest. Sipho is pushing this box to the right hand side with a velocity of 2 meters per second. So through a distance of 8 meters. So now they're asking how long it took. This is point A, this point B. How long it took Sipho to push this thing from point A to point B at this velocity? How long it took Sipho to reach point B? The one time, how long? The one time. We're still doing first law, guys. Don't be lost. So now, in this case, because now we don't have applied force, we don't even have force of friction, So what can we do now to calculate this? To calculate the time here. We know that to calculate the time we have to use kinematics equations. What is that? Velocity is the rate of change of displacement, right? This is displacement, not distance. It's displacement. Why I'm saying displacement, guys? I'm saying he travels from point A to point B. Now this is displacement because I have magnitude and direction. Displacement, it has magnitude and direction. Velocity, I'm saying he's pushing this box at this velocity towards the eastern side. So it also has direction. So this is also a vector. Displacement is a vector. It has magnitude and direction. It's a vector. And this one is also a vector, velocity. That's why I'm saying this is displacement, guys. So what is our time here? We're going to have to make T subject of the formula. So it's going to be time, velocity over this. No. So I will divide is D over T, D over V. D over V. So we have this formula. Now we can calculate the time took for this guy to bring this box to rest. So what is our D? It's 8. It's 8. Then divided by velocity is 2. So 2, 4, 6, 8 is 4. 4 seconds. It took him 4 seconds to reach this point B. So now we got our time. Now they're asking, what is the velocity? This is number 2. It's question number 2. What is the velocity? No, what is the acceleration of this box if final velocity is 10. So this guy pushes this from rest at this velocity. Now he increases speed to reach 10 meters per second. So now they're asking what is the acceleration, because he accelerated, he changed the speed. So what is acceleration? The acceleration is the rate of change of velocity. So from here, he moved the object with 2 meters velocity, 2 meters per second velocity, and then he reached point B with 10 meters per second. It means he increased his speed. Now his speed increased, so it means there is a change of velocity. Now there is acceleration on this box. Acceleration is the rate of change of velocity divided by the rate of change in time. So we have he accelerated. This is final velocity. They say calculate acceleration if he accelerates. If the final velocity is 10 meters per second. So they gave us final velocity now. So we have initial velocity. They gave us final velocity, which is 10 meters per second. And we also have time. So now velocity v final minus v initial divided by t final minus t initial. Initially it was at rest, and then initially it was at rest, guys. Initially it was at rest when he was at point A here, but he started moving with this velocity. So now they want to know what is the acceleration when he increased the speed to 10 meters per second. So we will take this as our initial velocity. So it's 10 minus 2 divided by 4. Because our final is 4. It's 4 seconds. And at the initial, time was 0 here. So 10 minus 2 is 8. Then 4 divided by 4, or 8 divided by 4. 8 divided by 4 is 2 meters per second per second. So our acceleration is 2 meters per second. So now they want to know what is the net force experienced by this object. Net force. What is that net force? Net force is equals to mass times acceleration. So can we want net force? Yes, we can want net force, because we have acceleration and now we have our mass, which is 4. So what is 4 times 6? What is 4 times 2? Sorry. What is 4 times 2, guys? 4 is our mass, and then our acceleration is 2. It's 8 newtons. So our F net is 8 newtons. So we have our F net. So now, yeah, we are done here. Because we got our F net. We are done. So if you understand what I have done here, go ahead and like the video, guys. You know, show the love, man. I'm trying here. I'm not a professor, man. I didn't even go to university. So go ahead and like the video. Support me. Show the love, man. Show appreciation. If you appreciate my content, if you appreciate what I'm doing here, it's not easy. Thank you, guys. Bye-bye.